have elaborately discussed the subatomic particles, electrons, protons, and neutrons, and how to calculate the mass of an atom, particle and wave nature of light, and Bohr's atomic model. For particle nature, we can use photoelectric effect, and for the wave nature, we can use Planck's theory. In the Bohr's atomic model, we can calculate quantized energy, quantized velocity, quantized radius of a particular orbit by using the formula. The word quantized means a fixed value. If you calculate velocity of an electron in the first orbit of hydrogen atom, it will be nearly 2200 kilometers per second. If it is the case, then how could the radius be possible with a fixed value? Electron moving here and there with a huge velocity, then how could it be possible to tell that it is a fixed radius from the nucleus? Isn't it? This is one of the drawback in Bohr's atomic model. Once again, the formula velocity v is equals to 2.18 into 10 power 6 z by n meters per second, where z is the atomic number, n is the orbit number, and radius r is equals to 0.53 into n square by z angstrom units. For first orbit, if you calculate for the first orbit from nucleus to first orbit, r is equals to 0.53 into n is equals to 1 for the first orbit divided by for the hydrogen atom z is equals to 1, you will get r is equals to 0.53 for the first orbit of hydrogen atom. So the value 0.53 itself we can call R naught or A naught. Sometimes they may give as R naught or sometimes they may give A naught. So both indicating that is the hydrogen atom first orbit radius. Okay. For any orbit, for any single electron systems like hydrogen, helium plus, lithium 2 plus, beryllium 3 plus, you can calculate R is equals to this 0.53 I can write as A naught or R naught into n square by z. Okay, this is for the calculation purpose. Sometimes they may give like this in the question in the options, so that you have to know about this point. Okay, not only velocity and radius, Bohr also calculated the energy. Energy is equals to minus 13.6 into z square divided by n square electronic volts. Okay, energy can calculate in terms of joules, but here particularly we are taking in electron volts because we are considering electron as a charged particle. Whatever the charged particle, we can relate it to electricity so that we can apply these fundamental concepts to our daily needs. That is the ultimate objective of our study. Comfort. Okay, so everything in Bohr's atomic theory was quantized. If you want to calculate radius of any particular orbit, you can calculate and you will get the fixed value. Not only radius, energy, velocity of any orbit, you can calculate and you will get the exact value. It indicates Bohr considered electron as a particle. That's why he calculated radius, velocity, energy easily, isn't it? This is the drawback of Bohr's atomic theory. Electron not only the particle, it is the wave also. Second thing, Bohr's theory is applicable for only single electron systems. But he didn't explain the structure of remaining atoms as we have nearly 120 atoms in the periodic table. Before moving to other drawbacks of Bohr, let me discuss two theories, de Broglie's theory and Heisenberg theory, so that we will get clear idea what he did and where he did the mistake. Okay? De Broglie's hypothesis. Hypothesis means assumption. Assumption. Every moving particle behaving like a wave, whatever the object which is present in planet Earth, having wave nature if it is in motion. This is his assumption. If I am running in this way, even I myself behaving like a wave, so that I can have lambda, wave number, and frequency, because I'm a wave. That's why these properties I can exist if I'm in a movement, in a motion. As we know, light photon having both wave nature and particle nature. Let me start with the light photon. Light photon having both natures, wave nature and particle nature. Wave nature can be explained by Planck, and particle nature can be explained by photoelectric effect. Energy of light photon E is equals to h nu. Nu is the frequency, h is the Planck's constant, and nu is equals to c by lambda. Lambda is the wavelength, c is the velocity of light. Nu is the frequency. That frequency term, if I am applying here, so that E will be hc by lambda. This is according to Planck's. E is equals to hc by lambda according to Planck's. Then, according to Einstein, energy of any object or particle E will be equal to mc square, where m is the mass of the object, c is the velocity of the object. This is from Einstein. So for the wave, E is equals to hc by lambda, and for the object, E is equals to mc square. This is for the wave, and this is for the object, whatever the object. Both are energy terms only, so that we can equate hc by lambda will be equal to mc square. C gets cancelled. H by lambda will be mc. Next, 1 by lambda will be equal to mc by h, and lambda will be equal to h by mc. The wavelength associated in the photon will be equal to h by mc. I'm applying for the light photon. That's why wavelength in a photon will be equal to h by mc. H is the Planck's constant, m is the mass of the photon, and c is the velocity of the photon. Velocity of the photon, you can take it as light velocity, whatever the photon, radio photon, X-ray photon, gamma photon, UV photon, whatever the photon, it is having same velocity, that is the velocity of light. If I am applying for the light, wavelength of photon will be equal to h by mc. Similarly, instead of photon, if I am applying this calculation on electron, which is moving in a Bohr's orbit, then lambda of an electron will be equal to h by mass of an electron and velocity of an electron. So instead of c here, I can write as v. Why? Because we calculated velocity from the Bohr's equation, Bohr's formula. I can write like this. This is the wavelength associated in a moving electron which is present in Bohr's orbit. Here, mv I can write as momentum, h by p. P is the momentum of electron. P is the momentum of electron. So, according to Debroglie, wavelength associated in an electron which is circularly moving in Bohr's orbit is equals to h by mv or h by p, where lambda is the wavelength associated in an electron, and h is the Planck's constant, 6.626 into 10 power minus 34 joule second, and mass m, mass of electron, we are calculating for the electron only. So I'm writing here mass of electron 9.1 into 10 power minus 31 kg, and v is the velocity of electron. Okay, let me do two calculations so that we can come to one conclusion where to consider this de Broglie's wavelength and where not to consider. Okay, the first calculation will be a moving object which is having 100 kg and the velocity 10 meters per second. And in the second case, I'm taking electron which is moving 10 power 6 meters per second with velocity 10 power 6 meters per second. These are the two cases. Both are moving particles only. Both can be behave like a wave. So both can be expressed in terms of wavelength. So lambda is equals to h by mv according to Debroglie. That will be 6.626 into 10 power minus 34 joule second and divided by mass 100 kg and velocity 10 meters per second. And here you can substitute these joules with kg meter square second power minus 2. That is nothing but joules. So that kg gets cancelled, meter 1 meter gets cancelled, second and this second will get cancelled. So that you will get approximately 6.626 into 10 power minus 37 meters. That will be the lambda. Which type of wave is this? Even our light photon wavelength starts from 10 power minus 12 meters. See here, gamma ray wavelength 10 power minus 12 meters. 10 power minus 12 meters. Here we got 10 power minus 37 meters. Very small value. Such type of wavelengths no need to consider. We can consider this wave as an object or a particle. So the moving thing is a particle or an object. You are not supposed to consider here the moving particle as a wave. Coming to the second case, electron is moving with 10 power 6 meters per second. If you calculate de Broglie's wavelength for an electron, that will be lambda is equals to h by mv. H will be the Planck's constant 626 into 10 power minus 34 joules divided by mass of electron 9.1 into 10 power minus 31 kg into velocity 10 power 6 meter per second. Meter second kg and you will get only meter. So that here 7.3 into 10 power minus 10 meters you will get the de Broglie's wavelength for an electron which is moving with velocity 10 power 6 meters per second. Maybe it may be present in an orbit or maybe it may be present in any other sources in electricity like other sources. Which type of wavelength is this? It is X-ray type wavelength. See here, if you compare this electron wavelength which is having velocity 10 power 6 meter per second, you will get exactly X-ray photon like wavelength. See here, it is comparable, not like a value 10 power minus 37 in the previous case. It is only 10 power minus 10 meter, which is comparable and significant. So the conclusion is if mass is very small, like electron, you will get significant wavelength. The lambda is equals to h by mv. If mass is increasing, lambda value will be decreasing. If mass is decreasing, lambda value will be increasing. So for the tiny particles, mass will be very low, so that maximum wavelength you will get. So the de Broglie's wavelength will be maximum for the tiny particles. That is the conclusion. For the tiny particles, the wavelength will be significant, but not the object which we are seeing in our day to day life, like balls and other objects. We can calculate wavelength, but it is not significant. For any object, you can calculate wavelength, but it is not significant. Till now, we have derived de Broglie's wavelength like lambda is equals to h by p or lambda is equals to h by mv. Now change this velocity term in kinetic energy. This velocity term in kinetic energy. We know Ke is equals to half mv square. Multiplying this mass of electron, mass of proton we know. So mass into kinetic energy will be equal to half of m square v square. I'm multiplying both sides. So m into ke is equals to half of mv, I can write as momentum p, so that p square. 2mke will be equal to p square. So p will be square root of 2m into ke. If you substitute this p value in the wavelength, h by lambda will be h by square root of 2m ke. This is one another equation. So first equation lambda will be h by p, second will be lambda will be h by mv, and third one lambda will be h by square root of 2m ke. Now imagine if an electron present in a circuit which is under potential difference V. I'm writing V like this because we are not supposed to confuse velocity V and potential difference V. Okay. So electron is moving in a circuit under the potential difference V. In that case, work done by the electron in electricity terms will be equal to EV. Work done by the electron will be equal to EV. E is the charge of electron, V is the potential difference. Charge of electron 1.6 into 10 power minus 19 coulombs. Charge means fire. If humans having certain vibrant nature, then we can say he is having fire, like our Pushparaj. Pushpa is not a flower, he is the fire. If humans having that nature, that will be fire. If particles having such type of nature, then that will be charge. But based on magnetic and electric fields, we can say positive charge and negative charge. Coming to potential difference, there must be some pressure to move electron towards positive terminal. Nothing but potential difference. In the equation, imagine E is the fire of King Kohli, V is pressure on Kohli. This is fire, inner fire of King Kohli, and V is the pressure of King Kohli. So first I'm applying less pressure, say 50 overs and 10 runs. Very less pressure. In the less pressure conditions, the outcome will be work done will be less. Even though King Kohli having good fire, the work done will be less. But the same time, if I am applying 50 overs in 50 overs 300 runs, means maximum pressure I am applying. In such cases, by multiplying his inner fire, the work done will be maximum. So in electrical terms, work done will be E into V. E is the charge and V is the potential difference. So this is the charge, this is the fire, and this is the pressure. Pressure difference. But this work done will be equal to kinetic energy. Directly remember here, this electrical work will be equal to kinetic energy because electron is moving towards positive terminal. So that Ke will be equal to E into V. Now, if apply Ke in de Broglie's wavelength equation, as we discussed in last slide, H by P will be equal to lambda and H by mv equal to lambda and H by square root of 2m ke will be equal to wavelength, and here I am applying ke in terms of electrical energy like ev. Okay, so E is the charge of electron, V is the potential difference. Here E not only here E not only for the electron, you can apply for any charged species, charged particle which is moving under potential difference V naught or V. Potential difference I can consider potential difference, potential difference will be V. Only for charged species which are accelerating or moving with V potential difference. If you apply H value 6.626 into 10 power minus 34 joule second and square root of 2 into mass of electron 9.1 into 10 power minus 31 kg and charge of electron 1.6 into 10 power minus 19 coulomb into potential difference I am writing as such. They'll give in the question. So that will be after doing calculation for this term you will get 150 under root of 150, so that overall 150 by V is the potential difference, that will be the lambda. Now I can write all the equations for de Broglie's wavelength. Lambda will be equal to h by p is the momentum, which is equals to mv, h by mv, and next h by, in terms of kinetic energy, square root of 2m ke, next h by square root of 2m into ev, and for particularly for electron, square root of 150 by v. After applying mass of electron and charge of electron, you will get particularly square root of 150 by v. This is for electron only. Why? Because we are applying mass of electron and charge of electron. After substituting all the values, we are getting the square root of 150 by v. This is for any charged species, any charged particles which are accelerating with v potential difference, which are moving with v potential difference. If you are seeing in the data kinetic energy, you can apply like this. You can apply this equation, lambda is equals to h by square root of 2m ke, and momentum p. If you know mass and velocity, you can apply lambda will be h by mv. Okay. And one more thing, there is a good agreement between Bohr's theory and de Broglie's theory. I mean, Bohr's theory accepted by de Broglie. According to de Broglie, lambda is equals to h by mv, right? He defined circumference of Bohr's orbit. Circumference of Bohr's orbit 2 pi r is equals to n lambda. 2 pi r, circumference of a circle will be 2 pi r, and n number of wavelengths are present throughout the circle. Bohr said electrons are moving in circular orbits. De Broglie said electrons moving like a wave with circumference 2 pi r. The circumference of any orbit will be 2 pi r as electron moving in a circular orbits. De Broglie consider these circular paths as a wavy paths of different wavelengths. I personally named de Broglie as a wavy de Broglie because wherever, whatever the thing, he said that it is the wave. It is the wave. Moving electron is a wave, moving x is a wave, y is a wave, and so on. Okay, so the circumference of 2 pi r is equals to n lambda. For the first orbit, 2 pi r is equals to 1 lambda. 2 pi r is equals to 1 lambda. For the second orbit, 2 pi r is equals to 2 lambda. This is for first orbit and this is for second orbit. Okay. For the third orbit, 3 lambda, fourth orbit, 4 lambda, like that. For the seventh orbit, circumference 2 pi r is equals to 7 lambda for seventh orbit. See here, 2 pi r is equals to, for the first case, 2 pi r is equals to lambda. So only single wavelength. Two wavelengths are present here. This is first wavelength and this is second wavelength. So total circumference 2 pi r is equals to 2 lambda for the second orbit. And the third orbit, this is lambda, and this is one more lambda, and this is one more lambda. Total circumference of Bohr's orbit will be equal to 3 lambda for the third orbit. So electron is not moving in a circular orbit, it is moving like a wavy paths as n equal to number of orbit, and lambda will be the wave number. Okay, see for the fifth orbit, first lambda, second, third, fourth, and fifth. So for the fifth orbit, according to Bohr, it will be like this: 1, 2, 3, and 4, and 5. But according to Debroglie, it will be like this. For the fifth orbit, nucleus. So fifth orbit only I'm writing 1, 2, 3, 4, and 5. Okay. Finally, 2 pi r is equals to n lambda. 2 pi r is equals to n lambda. N is the principal quantum number. N is the orbit number. This is the wavelength, particularly electron moving in circular Bohr's orbit. Electron moving in circular paths. Okay. In general terms, De Broglie suggested lambda of any object will be equal to h by p, and h by mv. And here from the first equation, lambda we can write lambda will be 2 pi r by n. This is the first equation. And this is the second equation. Both are lambda terms only. Equate it. 2 pi r by n will be equal to h by mv. Okay. Take this 2 pi r here. And after rearranging, nh by 2 pi will be equal to mvr. This is the postulate, one of the postulates of Bohr's atomic theory. In this way, Bohr's atomic theory and de Broglie's hypothesis both coincide each other. Okay, here you have to remember the only thing, 2 pi r is equals to n lambda. 2 pi r is equals to n lambda. To solve the problems, this is the one of the equation, and second one, lambda will be h by p. Wavelength of any object will be equal to h by p, h by mv, and h by, in terms of kinetic energy, 2m/ke. For the moving accelerating charged particle, square root of 2m ev, where v is the potential difference, particularly for electron, square root of 150 by v. They may ask lambda by giving some data, lambda of any object or any charged particle or electron. So you have to consider only how to calculate lambda. What is the wavelength of accelerating proton, or what is the wavelength when the particle is moving this much velocity and this much mass, or what is the wavelength if electron is accelerating by some x amount of potential difference. So they may ask like this, they may ask wavelength, and they may ask 2 pi r is equals to n lambda based questions. Heisenberg said it is impossible to determine both the position and momentum of an electron simultaneously and accurately. If we fix momentum, there is a deviation to calculate position. And if we fix position, there is a deviation in velocity. Obviously, electron moving 2200 kilometers per second. Then it is impossible to calculate both the terms simultaneously and accurately. Electron is moving that much fast. Heisenberg calculated this deviation and formulated as delta x into delta p is always greater than or equal to h by 4 pi. H by 4 pi. Delta x is the change in position, and delta p will be change in momentum. He is not calculating the exact values. Bohr already calculated. He is calculating the deviation from the exact value. Deviation is nothing but uncertainty. Okay, the deviation in position and the deviation in momentum is always greater than h by 4 pi. So whatever the value you calculated from Bohr's theory, it is deviated more than h by 4 pi. The value is always more than h by 4 pi. That is the Heisenberg uncertainty principle. So the first thing I wrote, delta x into delta p is greater than or equal to h by 4 pi. And we know momentum p is equals to mv. P is equals to mv, mass into velocity. If you substitute p is equals to mv, then I can write like this. Okay, there is no deviation in mass. Mass is always calculated as an exact value. There is no deviation in mass. So we can write delta x into delta v is greater than or equal to h by 4 pi m. This is the first form of Heisenberg uncertainty principle, and this is the second form. So this is the first form, and this will be the second form. Okay, and next, along with this, you directly remember uncertainty in energy and uncertainty in time is also greater than or equal to h by 4 pi. This is the third form. Delta E into delta T will be greater than or equal to h by 4 pi. Delta X into delta V is greater than or equal to h by 4 pi m. And next, delta X into delta P is greater than or equal to h by 4 pi. These are the three formulae suggested by Heisenberg. While solving the problems, we will consider these deviation, this uncertainty is exactly equals to h by 4 pi. I mean, while solving the problem, delta x into delta p is equals to h by 4 pi. You have to solve like this. Or delta x into delta v is equals to h by 4 pi m. Or delta e into delta t is equals to h by 4 pi. You have to take equality here. Means we are considering the uncertainty is not more than h by 4 pi. We are considering that is not the exact uncertainty. Okay, for suppose, say uncertainty in velocity 1%. Sometimes they may give in percentage. So in that case, you should convert that percentage into some value and do the calculation. Say the uncertainty in velocity 1%. Uncertainty in velocity 1%. And electron moving with velocity 10 power 6 meters per second. Okay, it means in the 10 power 6 meters per second, 1% is the uncertainty. Uncertainty they gave in percentages. So in the value of 10 power 6 meters per second, 1% is the uncertainty. It is the uncertainty. So calculate that 1%. Means you have to convert that percentage into the value. So uncertainty will be uncertainty in velocity will be change in velocity will be 10 power 6 is the value in that 1%, so that you will get 10 power 4. So change in velocity, uncertainty in velocity will be 10 power 4. You should calculate in this way. Okay, the problems for two particles A and B, curves are plotted root V against Debroglie's wavelengths. Okay, Debroglie's wavelength and potential difference. Which of the following relation is correct about the mass of particles? We connected de Broglie's wavelength and potential difference by lambda is equals to h by square root of 2mqv. Okay, here whatever the graph, they'll give like one parameter y and another parameter x. Y versus x means, if suppose take velocity versus distance, that means it indicates velocity is on y axis, distance is in x axis. You have to take like that. So whatever the graph, write the equation in the form of y is equals to mx plus c, or y is equals to m by x, or y is equals to e power x, like that. Okay, if y is equals to mx plus c, then the equation will be like this with positive intercept. If y is equals to mx, the graph will be like this y x, and the graph, you will get the graph which is passing through the origin. Y is equals to m by x graph will be like this. If y is equals to m by x square, the graph will be like this, same y and x. If x cube, it will be much more like this. Okay, y is equals to e power x, so the graph will be like this. These graphs and all you have to remember. And here the graph is in the form of y is equals to m by x. Y is equals to m by x. They already wrote the graphs in the same manner. See here, on the y axis they are taking root v. So keep root v like this. Then root v is equals to h by square root of 2mq and lambda. Okay, so this is the y, and this total will be m, and this is x. So our graph will be y is equals to m by x type graph. Okay, here they are connecting root v and lambda with mass. Okay, root v is inversely proportional to root m, right? If root v increasing, root m will be decreased. Okay, so keep lambda constant. Keep lambda constant means take a fixed point and take the same fixed point at a and at b. Now I'm keeping lambda constant. You can keep even root v also. After fixing, see the relation with root v and m. So root v and mass, they are inversely proportional. If root v is increasing, mass will be decreased. So root v is increasing in case of b, right? See here the maximum value, this is the minimum value. If root v is increasing, if root v is maximum here, the mass will be minimum. Mass of b will be minimum compared to mass of a, because they are inversely proportional. Okay, that is the answer. Plus 3 and proton are accelerated by the same potential. They are accelerated by the same potential. V is same. Potential difference is same. Their de Broglie's wavelengths have the ratio. So the ratio of de Broglie's wavelengths of beryllium plus 3 and de Broglie's wavelengths of proton we have to compare. And V is same. Potential difference V is same. So the de Broglie's wavelengths in terms of potential difference, we can write h by square root of 2mqv of beryllium plus 3 divided by h by square root of 2mqv of proton. Okay, h 2 2, same potential difference according to data. So potential difference and potential difference. Next, the remaining terms 1 by square root of m into v, m into q of beryllium plus 3 divided by 1 by square root of m into q of proton. That will be 1 by mass of beryllium, hydrogen, helium, lithium, beryllium. See the first video. In the first video we discussed elaborately how to remember the first 30 elements atomic mass units. So you can see beryllium, nitrogen, at least beryllium and nitrogen, these two are exception. Okay, remember this. Next, q, charge plus 3 divided by 1 mass of hydrogen 1 and charge on hydrogen 1. So that 1 by 3 root 3, this will be the answer. Okay, next, the momentum in kg meter per second of photon having 6 mega electronic volt. Mega means 10 power 6. Mega means 10 power 6. So energy they gave 6 mega electronic volt. 6 into 10 power 6 electronic volts. Okay. The momentum they are asking. P they are asking. What about P? They are giving energy. Photon means this is the light particle. Light particle energy. Light particle energy E is equals to hc by lambda. We can happily apply this formula. So energy they give hc by lambda they give. That means momentum is the characteristic for particles, and energy in terms of wavelength is characteristic for waves. Okay. So wave particle duality, nothing but de Broglie's hypothesis. They are asking on the basis of de Broglie's hypothesis. Okay. Next, momentum. Momentum we can write lambda is equals to h by p. Substitute this lambda value here. So E is equals to hc by h by p. That will be hc into p by h. You will get c into p. C is the velocity of light, p is the momentum. So we got finally E is equals to Cp. Energy they gave 6 mega electronic volts. 6 mega electronic volts, right? Energy 6 into 10 power 6 electronic volts. Okay, that will be equal to photon velocity. C is the velocity here. Photon velocity, whatever the photon, UV, visible, radio waves, gamma, X-rays, whatever the photon, that velocity will be equal to velocity of light. So 3 into 10 power 8 meters per second. Momentum we have to calculate. Momentum in terms of kg meter per second. Kg meter per second. Meter is there, second is there, but here electronic volt is there. Convert into kg meter per second means first convert into joules. That will be 1.6 into 10 power minus 19 joules. 19 joules. Joules means what it means joule. Joule means kg meter square second power minus 2 is nothing but joules. The same thing I am writing. Kg meter square second power minus 2 will be equal to 3 into 10 power 8 meter per second and into momentum. So meter gets cancelled. Second power minus 1, second power minus 1 gets cancelled. You will get answer in kg meter second power minus 1. Kg meter second power minus 1. That is the thing they are asking in the question. Okay. Next, by dividing this thing, you will get answer 6 into 10 power 6 into 1.6 into 10 power minus 19 divided by 3 into 10 power 8 will be momentum. That P will be 3.2 into 10 power minus 21 kg meter per second. This will be the answer. Okay. An electron travels with a velocity of x meter per second. So velocity of electron is x meter per second. For a proton to have the same de Broglie's wavelength, so electron wavelength and proton wavelength is same. The velocity will be approximately velocity of proton approximately. They are asking this thing. Okay. Lambda, de Broglie's wavelengths in terms of velocity. Lambda is equals to h by mv. Right? Apply this thing. For a proton have same de Broglie's wavelength, the velocity will be approximately. Okay. So here lambda same. So h by mv of electron will be equal to h by mv of proton. Right? H gets cancelled, and next mass of electron 1 by 1836 atomic mass units into, why, because we are comparing with electron and proton, so we have to take here relative atomic mass unit, not absolute one. If you are taking in kg something something, then you have to take absolute atomic mass units, absolute mass units. Okay. Next, velocity of electron they gave x meter per second. That will be equal to 1 by mass of proton. Mass of proton is 1. And velocity of proton will be, velocity of proton we have to identify velocity of proton. So that will be x divided by 1836 will be equal to velocity of proton. Okay. Here proton means H plus ion is nothing but proton. Actually, proton is the subatomic particle. If you take hydrogen atom nucleus is having one proton, single proton, and hydrogen atom also having one electron, one proton and one electron. So neutral atom, hydrogen neutral atom. After removal of one electron, after removal of one negative charge, you will get only one positive charge. That will be that we can write as H plus ion. This H plus ion is nothing but single proton. It is representing only single proton. So H plus ion is nothing but proton. Okay. Calculate the mass of photon whose wavelength is 3.6 angstrom units. Lambda 3.6 angstrom units. Photon, it is the light particle. Okay. Lambda 3.6 angstrom units. They are asking mass for the particle, lambda for the wave particle duality, nothing but de Broglie's concept. So lambda will be h by p, that will be h by mv. Lambda they gave 3.6 into 10 power minus 10 meters is equals to 6.626 into 10 power minus 34 joule second divided by mass of photon we have to calculate, and v is the velocity of light, 3 into 10 power 8 meters per second, right? Whatever the photon we have to take only velocity of light photon whatever it may be, x-ray, gamma ray, uv ray, visible, radio waves, hmm, cosmic rays, whatever the photon you have to take the velocity 3 into 10 power 8 meters per second. So after calculating this you will get mass will be 6 into 10 power minus 33 kg. Okay. Next, if a naught be the radius of first Bohr's orbit, generally radius we will calculate, radius of any orbit will be 0.53 into n square by z angstrom units. If you calculate for the first orbit, that will be 0.53 hydrogen atom n. For the first orbit, n will be 1, a hydrogen atom z will be 1. So that first, the first orbit radius will be 0.53. The value itself we can call as r naught or a naught. The radius of first Bohr's orbit will be r naught or a naught. Okay, a naught. So they are denoting this one with a naught. And the de Broglie's wavelength of an electron, de Broglie's wavelength of an electron revolving in the second Bohr's orbit will be second Bohr orbit. Second Bohr orbit. So according to de Broglie, electron will revolve like this. The circumference 2 pi r is equals to 2 lambda. For the second Bohr orbit, 2 pi r is equals to 2 lambda. Okay, here radius of the second Bohr orbit. Radius I'm writing directly 0.53 into n square divided by z angstrom units, and that will be equal to 2 pi. Okay, 2 gets cancelled. Pi into 0.53 into 4, 2 pi r is equals to 2 lambda here. 2 lambda. That will be lambda. This 0.53, they have given a naught. So pi a naught 4 is equals to lambda. Okay, this is the de Broglie's wavelength in terms of a naught. The mass of a particle is 10 power minus 10 grams. So mass is equals to 10 power minus 10 grams, not in kg. And next radius 2 into 10 power minus 4 centimeter. Okay, then velocity, if velocity is 10 power minus 6 centimeter with 0.0001%, so in the velocity the uncertainty will be some percentage. In the velocity uncertainty is some percentage. So calculate the exact value of uncertainty. I mean, if your velocity is 10 power minus 6, in this velocity uncertainty is 0.0001 percentage. So calculate the exact value, so that that percentage I have to remove, divided by 100. That will be 10 power minus 12, 4, 5, 6. Total 12. 12, this is in centimeter, so that this will be in centimeter. Okay, this is the uncertainty in velocity. This is the uncertainty in velocity. This is the exact value, and with the exact value I have multiplied with the percentage, so that I am getting uncertainty in velocity. And they are asking uncertainty in position. So delta x into delta v is equals to h by 4 pi m, right? And they are asking position, that will be h by 4 pi m into delta v. Okay, substitute here. Delta x is equals to h by 4 pi m h by 4 pi m m 10 power minus 10 grams. That means 10 power minus 13 kg. Why? Because I'm taking joules here. Planck's constant in terms of joules. Joules is nothing but kg meter square second power minus 2. So that's why I'm converting here in kg. And next 4 pi m delta v is 10 power minus 12 centimeters. So 10 power minus 14 meters. Okay, 10 power minus 14 meters. Okay, then delta x, after calculating all the things, you will get delta x will be 5.2 into 10 power minus 8 meters. Okay, if an electron is traveling at 200 meters per second, so velocity they gave velocity 200 meters per second within 1 meter per second uncertainty, it is not in terms of percentage, directly they gave the value with the uncertainty 1 meter per second, directly they gave the value uncertainty value. What is the theoretical uncertainty in its position? So position uncertainty we have to calculate. According to Heisenberg, delta x into delta v, position in uncertainty in position and uncertainty in velocity will be equal to h by 4 pi m. Okay, delta x we have to calculate in terms of micrometer. Delta x into delta v, they gave directly 1 meter per second, 6.626 into 10 power minus 34 joule second divided by 4 into 3.14 into, this is electron, so electron mass 9.1 into 10 power minus 31 kg we have to apply, so that delta x will be some 58 into 10 power minus 6 meters. You will get the answer. Okay, if the de Broglie's wavelength of the electron in nth Bohr orbit in hydrogenic atom is equals to 1.5 pi a naught. De Broglie's wavelength is equals to 1.5 pi a naught. Okay, a naught is the Bohr's radius. First Bohr's radius, first orbit's radius is nothing but Bohr's radius, a naught. Then the value of n by z is value of n by z we have to calculate, n by z value we have to calculate. Okay, here they are connecting wavelength and radius, Bohr's radius, wavelength radius relation, that will be 2 pi r is equals to n lambda, 2 pi r is equals to n lambda. Okay, next, here nth Bohr orbit, nth Bohr orbit I am writing like nth Bohr orbit radius I am writing 0.53 into n square by z angstrom units, and that will be equal to n lambda. Okay, this 0.53 I can write as a naught as we discussed in the previous question. So a naught into n square by z will be equal to n lambda. N gets cancelled. 2 pi a naught into n by z is equals to lambda. Okay, n by z value we want. So n by z is equals to lambda divided by 2 pi a naught. And in the data they gave lambda value. So n by z is equals to 1.5 pi a naught divided by 2 pi a naught. A naught pi pi. So that n by z will be 1.5, 0.75, 0.75. There is no units. Find the ratio of de Broglie wavelength of a proton and an alpha particle with which being accelerated through the same potential difference. Potential difference same, V is same in both the cases. And alpha particle is nothing but helium 2 plus. Helium 2 plus. De Broglie's wavelength of proton and de Broglie's wavelength of helium plus 2 ratio in the terms of potential difference. So h by square root of 2mqv of proton divided by h by square root of 2mqv of helium plus 2. Okay. Next, H2 2 and same potential difference. Potential difference, potential difference. The remaining terms 1 by square root of m into q divided by 1 by square root of m into q of helium. Okay, this is helium plus 2 and this is for proton. Proton mass 1, proton charge plus 1, helium plus 2 mass, helium plus 2 in the helium nucleus. This is the helium atom. In the helium atom, the nucleus, in the nucleus it is having two protons and two neutrons. So the weight of mass of helium atom will be 4 atomic mass units. But here helium plus 2 electrons, you have to remove 2 electrons. Even though you are removing 2 electrons, there is no change in the atomic weight. So 4 atomic mass units. I can substitute the values here. 1 by square root of mass of hydrogen, charge of hydrogen into square root of mass of helium, 4 atomic mass units, and charge on helium 2 divided by 1. That will be square root of 2 root 2. Simply you can write 2 root 2 by 1. Okay. An electron An electron has a speed of 40 meters per second, accurate up to 99.99%. Accuracy they gave. What is the uncertainty in locating its position? Delta x they are asking. Uncertainty in position. Accuracy in velocity they give. We don't want accuracy. We don't want accuracy. We want only uncertainty. Okay, so if accuracy is 99.99 percentage, uncertainty will be remaining percentage. 0.01 percentage will be the uncertainty in the exact value. So uncertainty in velocity delta v will be 40 meters per second they give. So in the 40 meters per second, that will be 0.01 percentage. Okay, so that 0.004 meters per second. Now you can calculate delta x into delta v is equals to h by 4 pi m. That will be delta x is equals to h by 4 pi m into delta v. That will be 6.626 into 10 power minus 34 joules divided by 4, 3.14 into mass of electron 9.1 into 10 power minus 31 kg into velocity 0 point, as we calculated uncertainty in velocity 0.004 meters per second. Zero point 0.4 into 10 power minus 2 meters. Okay, these are the problems. So there is nothing special, there is no logical thinking behind these problems. Simply we have to apply the formula. There is no much rocket science in this. You can simply apply the formula, apply the units carefully. Okay, the next class we'll discuss quantum mechanical model of hydrogen atom and quantum numbers, and the remaining topics like stopping potential, Rutherford's model, we will separately discuss at the end of the chapter. Okay, this is what about Debroglie's hypothesis and Heisenberg's uncertainty principle. Thank you, thank you, thank you, thank you, thank you, thank you.